Hamming coding. Next one is Hamming coding. Hamming coding is next topic is Hamming coding. Hamming coding is Hamming coding is Hamming coding in a computer network. Hamming coding in a computer network. Hamming coding is a computer network. Hamming code is a set of error correction codes. The Hamming coding is a set of error correction code. Error correction code that can be used to detect and correct the errors. The set of error correction codes that can be used to detect and correct the errors that can occur when the data is moved. When the data is moved or started from the errors moved the data that can when the data is moved and stored from the sender to the receiver. Sender to the Hamming code in a computer network. Hamming code is a set of error correction codes that can be used to detect and correct the errors that can occur when the data is moved and stored from the sender to the receiver. Data is moved from sender to the receiver, and Hamming code is a block of codes that is capable of detecting up. The Hamming code is a block of data that is applicable for the data that is applicable for that is applicable for the Hamming code is a block of code is code that capable of detecting of two simultaneous bit errors or correcting signal bit errors. It was developed by R.W. Hamming for error correction using the same formula as in encoding for error correction using for error correcting continuously bit errors and correcting signal bit errors. It is developed by R.W. Hamming for error correction using the same formula as in encoding. The number of redundancy bits are asserted. There will be 2 to the power of r greater than or equal to m plus r plus n, where m is the number of data bits, r is the number of redundancy bit. The 2 to the power of r greater than or equal to m plus r plus 1, m plus r plus m plus r plus 1. R plus 2 to the power of r greater than or equal to m plus r plus 1, where m is the number of data bits. M is the number of data bits. The encoding RW for error correction using the same formula as an encoding the number of redundancy bits are redundancy bits are redundancy bits are redundancy bits are redundancy bit using the same formula. छोड़ रहा है छोड़ redundancy bit using the same formula as an encoding the number of redundancy bit are asserted. There is a formula we have to maintain that 2 to the power of r greater than or equal to m plus r plus 1, where m is the number of data bits, r is the number of redundancy bits, 2 to the power of r greater than or equal to m plus 2 to the power of r greater than or equal to m plus r plus 1, where m is the number of data bits, and r is the number of small r is the number of redundancy bits. And the next slide is moving to this and various there we have to the condition we have to maintain the Hamming coding is a blocks of data. Then we have to various steps. R is the redundancy different position of the redundancy bit. There R is the redundancy bits place rate bit position of power of 2, that is 1 4 1 2 4 8 16 extras. The R is the redundancy bit place rate bit position of power of 2, that is 1 4 1 2 4 8 16. Step 3, parity checking. The parity checking with parity bits are calculated based upon the data bits and redundancy bits using the same rules and during the generation of codes C1, C2 and C3 and C4. The Hamming coding we have to error detection. Hamming coding for error detection. As we go through the example, the first step is to identify the bit position of the data. All the bit position which are the power of 2 are marked as a parity bits. The example of 1 2 4 8 extra. The following image will be helpful visualizing the received Hamming code of 7 bits. As we have the example, the first step, identify the bit position of the data. All the bit positions which are power of 2 are marked as a parity bits, and example of 1 2 4 8 extra. The following images will be helpful visualizing the received Hamming code of 7 bits. The first we needed to detect whether there are any errors in this received Hamming coding, and then we have to get this data is the 4 bit 8 bit that has the P1 is the parity bit, P2 is the parity bit, and D3 is the data, and P4 is the parity bit, and D5 is the data, and D6 is the data, and D7 is the data. Parity bit is P1, and parity bit is P2, and parity bit is P3. Then we have to go to the as we as we observe that as we observe that as we as we observe that as we observe total number of bits are added, total number of bits are odd, so we will write the value of parity bit as p1 is equal to 1. This means the error is there. Step 2 is check for p2, but while checking for p2 we will use check 2 and skip 2 method which will give us the following data bits. But remember, since we are checked for p2, and so we start our count from p2, and p1 should not be considered. p2 should not be considered. The p2 is equal to 1 data d3 d6 and d7. And then next slide is moved for next slide is going to be as we observe that the number of ones are even, then we will write the value of p2 is equal to 0. This means there is no error. Step 3 is check for p4, but while checking for p4, and we will use check 4 and skip 4 methods which will give us the following data bits. But remember, since we are check for p4, so that we have started our count from p4, and p1 and p2 should not be considered. On the next slide we'll be moving to this next slide. We have to, as we observe that the number of ones in the even, then we will write the value of p2 is 0. This means there is no error. Step 3 check for p4, but while checking for p4 we will use check 4 or skip the 4 methods which will give up the following data bits. But remember, since we are checking for p4, so we have to start our count from p4. p1 and p2 should not be considered. Next slide is moving to be, as we know that observe that the number of ones odd, then we will be write the value of p4 is equal to 1. This means there is no error. This means the error is there. And so from the above parity analysis, p1 and p4 are not equal to 0, and p1 and p4 are not equal to 0. So we can clearly say that received Hamming code as error. Receiving Hamming code is error. p4 and d5 d6 and p4 d5 d6 and d7. p4 and d5 and d6 and d5 and d6. Next slide, as we observe that the number of ones are odd. Then we will write the value of p4. p4 is equal to 1. This means the error. This means that the error value of p4. This means so from the above parity analysis, p1 and p4 are not equal to 0. p1 and p4 are not equal to 0. So you can clearly say that the received Hamming code is an error. Then clearly, so we have to clearly say that the Hamming code is the error. Then we have to then we have to check this. Then we have to we have to we have to you have to we have to we have to use we have to use for that advantages of having code. Advantages of having code. Having code method is effective. Having code is method for effective networks. Networks where the data streams are given for single bit error. Advantages of Hamming code method is effective on networks where the data streams are given for a single bit error. Hamming code not only provides the detection of a bit error, but also helps you to intend bit containing errors so that if it can be corrected. Hamming code not only provides the detection of the bit error but also help you to intend bit containing errors so that it can be corrected. The easy of uses of Hamming codes makes it a best of them suitable for use in uses in computer memory. Single error correction. The easy uses of Hamming codes checks makes it best them suitable for uses in computer memories and also single error correction. Then we have to go to the disadvantages of Hamming code. Disadvantages of Hamming code is single bit error detection and correction code. Single bit error detection and correction code. However, if multiple bits are found error, if multiple bits are found error, then outcomes may result in another bit which should be corrected to be changed. And may result in another bit which should be corrected to be changed. This can cause the data to be thus can cause the data to be further error. Hamming code algorithm can solve only single bit issues. Hamming code algorithm can solve only single bit issues. Applications of Hamming code. Here we have some common applications of using Hamming code. Here are some common applications of using Hamming code satellites. Hamming code satellites used in Hamming code in satellites and computer memories and computer memories and computer memories to storage of information. Modems, it can also used in modems are modulation and demodulation. Modem is converting of any analog signal converted into a digital signal into a digital signal, and after that digital signal are converted into analog signal. Digital signals are converted into analog signal. Modem is modulation and demodulation. It converts analog into digital signal. To convert a modem is analog to digital and digital to analog, basically in the modems. Plasma cam is also plasma cam. This can also used for Hamming coding techniques. Hamming code techniques also used in plasma cam and open connectors, and also used in open connectors shielding wires. It can be shielded by the wires shielding the wires. And also this can also be used for embedded processor. It also can be used for the embedded processor. This can also used for the embedded processor. This can also used for embedded system. This can also used for the embedded system. Next slides, applications and disadvantages and applications. These all are the Hamming coding techniques are used to detecting the errors. These all are the Hamming coding for detecting the errors. Hamming coding for detecting the errors. The Hamming coding is find out the errors. The condition Hamming code is block of a code that capable of detecting upon two simultaneous bits. Two simultaneous bits. This can also use it for data communication. Hamming code Hamming coding is code for network Computer code network haming code is a set of error correction codes that can be used to detect and correct the errors that can occur when the data is moved from or stored from the sender to the receiver. And the Hamming coding is converted into a blocks of data that can be converted into a blocks of data to blocks of data and Hamming coding, error correction and error detection. Hamming coding is a blocks of code are capable of detecting upon to simultaneously bits error and correcting single bit using the formula is encoding the number of redundant bits. The number of redundant bits are asserted using the same formula for as in encoding. The number of redundant bits are asserted 2 to the power of r greater than or equal to m plus r plus 1, where m is the number of data bits, where r is the number of data bits, and small r is the number of redundancy bits. Small r is the number of redundancy bits. Therefore, the condition is Hamming scientist will be maintain the condition is 2 to the power of r greater than or equal to m plus n plus r plus 1, where m is the number of data bits, small r is the number of redundant bits. Number of redundant bits. Position of redundant bits. Position and redundant bits. R is the redundant bits placed at a bit position of power of 2, that is 1, 2, 4, 8 and 16. The redundant bits placed at a bit position of power of 2, that is 1, 2, 4, 8, 16 extras. Step 3. Parity checking. The parity bits are calculated based upon the data bits. Based upon the data bits and the redundant bits using the same rules as during generation of C1, C2, C3 and C4. The next slide is here. C1 is the parity. Parity is the taking the position if it is 3 bits. Weighted code 1, 2, 4, 8. I have written as a decimal numbers into binary. 0 is 0, 0, 0, 0, 1 is equal to 1, 0, 0, 0, and 2 is equal to 0, 1, 0, 0, 3 is equal to 1, 1, 0, 0, 4 is equal to 0, 0, 1, 0, 5 is equal to 1, 0, 1, 0, 6 is equal to 0, 1, 1, 0, 7 is equal to 1, 1, 1, 0, and 8 is equal to 1, 0, 0, 0, and 9 is equal to 1, 0, 0, 1, 10 is equal to 1, 0, 0, 1, 0, 10 is equal to 1, 0, 1 0 10 and 11. In this way we have to find out the C1 is the parity. C1 is the parity. C1 is the parity is the odd numbers 1 3 5 7, 1 3 5 7 9 11 and so on. C2 is the parity is equal to 3 2 3 6 2 3 6 7 10 11 and so on. C2 will be taken as the parity. C2 will be taken as the parity is equal to 4 7 and 12 15 and 20 23 and so on. The error correction, next step is going to be error detection and correction. Error detection and correction, the decimal equivalent of the parity bits, the decimal equivalent of parity bits of binary values is calculated. If it is 0, there is no error. If it is 0, there is no error. Otherwise the decimal values gives the bit position. The decimal values otherwise the decimal values gives the bit position which has error. Example for if C1 and C2 C3 C4 equal to 1001, it implies it implies it implies it implies it implies it is if it is 0 if it is 0 if it is 0 if it is 0 there is no error. Otherwise decimal values gives the position give the position. Otherwise the decimal values gives the bit position which is an error. For example of if C1 and C2 and C3 and C4 C1 and C2 and C4 is equal to 1001, it implies the data bit at a position of 9. Decimal equivalent of 1001 as error. The bit is flipped to get the corrected the message. Next slide is moving to be next slide is Hamming coding of error. As we go through the example, the first step is identity the bit position of the data. All the bit position which are the power of 2 are marked as a parity bit. Example of 1, 2, 4, 8. The following images will be help in visualizing a received Hamming code of 7 bits. I have considered the Hamming of 7 bits. Hamming code of 7 bits. First we need to detect whether there are any errors. It is received by Hamming bit that is equal to 7 bits. If it is 7 bits, the 8-bit data 1 2 3 4 5 6 7 bit data, then we have to consider as a 3 is the parity bit for checking the even parity or odd parity. Then we have to consider here the parity bit P1 P2 D3 and data is the P1 and P2 and data is the D3, and P4 and D5 and D6 and D7, and we have to consider as a P4 and P4 P1 is 1, P2 is equal to 1, P4 is equal to 1. The parity bit P1 and P2 and P4, the Hamming code. Then we have to get the first we need to detect whether there are any errors in the received Hamming coding. There are first we need to detect where there are any errors in the received Hamming code. For checking the parity bit P1, use check 1 and skip 1. P1, if it is considered taking as the even parity, check this P1, check the skip method means the starting of from P1 and skip P2 and take D3 in the skip P4, then take D5 and then skip the D6 and take D7. This is the way will have the following bits P1 and D3 and D5 and D7. P1 is equal to, if it is considered as the even parity, then we have to even, then P1 will be at 0. If it is odd parity, the odd parity that is equal to 1 1. Odd parity is equal to 1 1, then we have to take as the added to the P1 is equal to 1. Then we have to consider here, and as we observe the total number of bits are odd, we will write the value of parity bit is 1. If we had to consider even number, that even number 0, there is, as we observe the total number of bits are odd, so we will write the value of parity bit as P1 is equal to 1. This means error is there. Step 2, check for P2, but while checking for P2 which will give us the following data bits. Which will gives us following data bits, but remember, since we are checking for P2, we have to start our count from P2, and we have to P1 should not be considered, and P2 and D3, D6 and D7. I have to P2 is equal to 1, the even number added to the 1. Next slide is in this way, and next slide only we have to consider 4 bit. Similar way, we have to observe that the number of ones are even, we will be write the value of P2 at 0. We have to consider the bit is at P2, we have to insert 0. We have to count the data is even number, odd number, even number, then we have to P2 will be 0. This means that there is no error. And if it is considered as a data P1 will be considered as a P1 or P2. P1 and P2 here the block diagram. If it is P2, consider if D3, D6, D7. In this data bits, I have to take the even parity. If counted the data is equal to odd parity, data will be count to the odd parity, even parity. I have to consider 1 0 0, it is will be a odd number. Then we have to parity bit will be inserted to be a 1. P2 will be inserted to be a 1. Then we have to 1 0 0 1, that will be count the even number, that will be a parity bit. In this way we have to check this parity bit. As we observe that the number of ones are even, and there will be a write the value of P2 is equal to 0. This means there is no error. Step 2 and step 3. P4, I have to consider we have to P4, Then we have the number of ones are odd. Ones are odd, we will be read the value of p4 1. There is a no error. So from the parity analysis, p1 and p4 are not equal. So some there is an error and p1, p2 and p4. P1 and P2. Here we have observed that number of ones are odd. Then we will write the value of P4 is equal to 1. This means the error is 0. From the above parity analysis, P1 and P4 are not equal to 0. So then we clearly say that received ham encoding as an error. This is the way we have to find out these errors, error checking, and consider here we can consider the number of ones odd. If it is odd number, the data will be converted to even. If even, then we have to add it to the converted odd, the parity bit will be inserted into 1. If it is even number, then we have to, if it is even that checking number, if we have to even number of data is counted, that will be added to the 0. Then in this way we have to add the binary bits. This is for checking the Hamming code.